Good morning, afternoon, or evening, everybody. Welcome to the Exploring River Deltas with NASA Data, the Delta X mission Earth Data webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so let's go ahead and get started here. What I will do first is start today's webinar with just a few logistics. To ensure the best audio experience, all participants have been placed in silent mode, but if you have any issues or any questions, what I'd like for you to do is enter those into the Q&A panel rather than the chat, and you should see that located on the right side of your screen. If you don't see the Q&A panel, click on the three dots in the bottom right, I believe, or the bottom middle, and that should reveal your panel options, and then you can select your Q&A panel. Today's webinar is being recorded. The recording will be posted both to the NASA Earth Data website as well as to our NASA Earth Data YouTube channel within a week of completion. Once completed, I will send an email to all registrants and participants that includes links to both the recording and presentation slide decks used within today's webinar. As far as timing is concerned, today's event will be 1 hour and 15 minutes long, with 45 minutes allocated to the presentation and live demonstrations. A 15-minute Q&A period will follow, and then depending on the volume of questions we receive, we may extend the Q&A session an additional 15 minutes from end time, but we will have a hard cutoff of 3:15 p.m. I am also very pleased to welcome 3 members of the Delta X science team who will be joining us this afternoon for the question and answer session as panelists. We've got Dr. Alex Christensen, Dr. Ali Reza Payanda, and Dr. Antoine Soloy. All right, during this afternoon's event, we will have 2 speakers. And at this point, let me also pull up the agenda for you. Our first speaker for this afternoon is Dr. Kathleen Jones. Dr. Jones is a senior research scientist and also the deputy principal investigator for the Delta X EVS-3 mission at NASA's Jet Propulsion Laboratory. She will begin today's webinar with an introduction to NASA's Delta X mission, its measurements and data sets. And then from there, we're going to transition to our second speaker this afternoon, Dr. Yaxing Wei, who is a geospatial scientist and also the lead scientist at NASA's Oak Ridge National Laboratory Distributed Active Archive Center, or ORNL DAAC. Yaxing will conduct a series of Delta X data discovery and data access demonstrations, both through ORNL DAAC, Earthdata Search, and also the Earthdata Cloud. Excuse me. And then after this, what we'll do is we'll transition back to Dr. Jones, who will demonstrate how to search for Delta X data using the Delta X data portal. And she will also provide an example Jupyter Notebook Delta X use case. And so before I toss it over to Dr. Jones, let's cover a few things regarding the Q&A session. We'll try to answer all of the questions within the time allotted, but if we are not able to address your question during the Q&A period, our speakers will be able to follow up with you offline. With that, at this point, I will stop sharing my screen and I will toss it over to Dr. Jones. All right, let me stop sharing my screen. It is my pleasure to introduce our first speaker this afternoon, Dr. Kathleen Jones. And so Kathleen, let me get you hope you've already got the role. Perfect. All right. Thanks, everybody. I cannot hear your audio.
Yes, it would help if I turned it on.
Perfect. Thank you. Thank you so much, Dr. Jones. All right.
Thank you. Sorry. It's a great pleasure to be here today talking about the Delta X mission. I want to acknowledge Mark Samar, the PI for this mission, who asked me to give this presentation because he was unable to do that. Let's see, does this work? Okay, so Delta X is one of the Earth Venture-Suborbital missions. So NASA has a number of different missions that it competes, and the Earth Venture-Suborbital missions are supposed to use NASA's airborne assets to do unique science that can only really be done with the inclusion of airborne assets. So in the third selection of the EVS missions was done in 2018, and Delta X was selected at that time. It was actually the only one that looked at land processes. And in particular, it looked at something that's actually very relevant to what's going on around the world now, which is the resilience of river deltas. So there's an issue, which is that most of the medium and large-sized deltas around the world are losing land. They cannot grow fast enough to keep up with sea level rise. And this plot here shows the part of the issue, which is that sediment that comes into the delta is not able to elevate the delta plain far enough to offset sea level rise. But this model assumes that the entire delta is lost, when in fact some parts of a delta will be able to survive. In addition, it also assumes that there is no contribution to land building that is local to the delta. In other words, the marshes that build land locally in the delta through organic production are not included in this. So Delta X tries to address this by looking at whether deltas can survive in the next decades of sea level rise. And the way it does that is going from this bathtub scale to looking at a much smaller scale, so sub-island scale, think something like a hectare. And that's the scale at which these organic productions and sediment capture occur. In addition, by doing this, by understanding the processes that control land loss and gain, then you can look at how deltas can survive the next decades of rising sea level. So in order to do that, this study is inherently cross-disciplinary, because you have to look at the interdependence of hydrology, ecology, geomorphology. So that means that you have to look at the channel networks. How do the channels distribute sediment throughout a delta? Ecology. Where are the plants growing? How do they build organic soil themselves? And then geomorphology, the shape of the delta, the way that the delta is constructed, and how much sediment is coming in from the river. So in particular, our objectives were to evaluate the roles of vegetation on soil accretion rates, and also the channel network density and the delta island size on the soil accretion rate. And I want to point out that the role of vegetation is actually not solely related to organic soil production, because vegetation helps to capture sediment as it flows into an island. And if you have very, very dense vegetation, then in fact, it can prevent sediment from getting to the inside of an island, and therefore have a negative impact on sustainability. So this team is necessarily cross-disciplinary. It is a large science team, and I want to give credit to the co-investigators here. In addition to people from JPL, there are people from Caltech working on this. Louisiana State University is heavily involved, being a local university. University of Texas, Florida International University, University of North Carolina, and Boston University are also involved in this study. So Delta X framework, we're trying to predict long-term organic and mineral soil accretion at the sub-island scale throughout a delta. And in order to do that, you necessarily have to model it. You have to model the hydrology, hydrodynamics, sediment transport, and you have to model the organic productivity. And in order to do that for a particular delta, you have to have calibration and validation data for these models. So for Delta X, we used our airborne assets for providing part of that validation data, and we used a lot of field data. And I'm going to go on to talk a little bit about those, the data sets now. So, but first, I want to explain something about our study area. Our study area was in the Mississippi River Delta. It looked at two basins, which were right next to each other, the Atchafalaya Basin, which you can see here, the green, it's an active delta. It's actually gaining land. And so it's not cut off from sediment. A lot of land has been building, and it continues to the day. Right next door is the Terrebonne Basin. This is an inactive basin. It's been leveed, cut off from external sediment, and it is one of the areas that is most rapidly losing land in Louisiana. Now, everything else is the same about these two basins. You have the same climate, essentially the same weather, you have in principle the same vegetation types, and yet one is losing land and one is gaining land. And so this is a perfect study area for this particular, for Delta X. So we had, of course, our intent was to get calibration and validation data for the models. And so we had two airborne campaigns. The first was at high river discharge and low biomass, so that was in spring of 2021. And the second was at low river discharge and high biomass. And by looking at, in fall of 21, and by looking at that range, we were able to calibrate the models across a range of biomass and the range of river inputs. And we also had some data was collected in 2015 and 2016 in what we call the pre-Delta X campaigns. And that was done just to demonstrate the methods with the airborne instruments. So to go into a little bit more detail about the data that was acquired, there were 3 airborne instruments, 2 radars, UAVSAR and AirSWOT, and a spectrometer, AVERS-NG. And in addition, teams went out in boats to look at water flow and sediment, and there were teams in the field looking at the vegetation and the soil. The spectrometer, let's see, I think I missed one. There it is. The radars flew at the same time in order to capture different parts of the tidal cycle. In the spring, there were 3 flights, low tide, high tide, and receding tide. UAVSAR was used to look at water level change in areas where there was vegetation, and AirSWOT was used to look at water levels and water height and slope in the open water areas. The spectrometer was used to look at sediment in the water and also at the vegetation types across the area. In situ data was collected at the same time concurrently with these flights whenever it was needed for validating the airborne data, and also for the vegetation it was, and the soil properties, synchronicity was not required. There were a number of intensive study sites. The idea was to look at study sites in each of these basins that covered different types of vegetation in general. So there were freshwater sites in both basins, there were brackish water sites in both basins, and there were saline water sites in both basins. And by doing that, we also were able to cover the range of conditions for our validation models. The vegetation and soil sampling, we got above and below ground biomass, vegetation structure. Feldspar layers were laid out before the first campaign in order to go back and look at soil accretion on each half year in order to provide information for the organic soil production model and also for validation of the final model. Water quality, samples were collected in different parameters were carbon, organic content, those kinds of things were analyzed. ADCP was used to get currents. Water, we had 50 or so water level gauges. You can see here Mark Simard removing the very last one after the campaign was over. And we also collected a lot of information about grain size distribution, particularly as a function of depth and as a function of location within the delta. And that was done both in islands and within the channels. So UAV SAR flight pattern, we flew racetracks that captured the tidal propagation across the wetlands every 20 to 30 minutes. Each pair here was flown in a different flight. We would have a 6-hour flight roughly, collecting 5 hours of data for each of these areas. And then AirSWOT was added. You can see these small lines. They were over the open channels in order to get simultaneous data with the UAV SAR. And then the AVERSNG also imaged the entire area in order to get both the vegetations and all of the channel. Models, we have Delft3D as a hydrodynamic model. It includes sediment transport. We've delivered a 90-meter grid overall model, and with higher resolution at the intensive study sites. We've also done a 30-meter grid, and now we're doing a model that will have irregular grid, full domain. That will be available, or some of those are available already on the DAAC. We used NUGA, another model, hydrodynamic model, that is coupled with TELEMAC, which is a sediment transport and deposition model. And then there's a NUMAR model, which is from Louisiana State University, looking at organic soil productivity. So now I'm going to turn it over to Yaxing Wei, who's going to talk about how to find all this data at the Oak Ridge National Lab DAAC. Thank you.
Thank you very much, Kathleen, and hope everyone can hear me okay. Let me quickly share my screen. Okay, great. Hi, everyone. Again, I'm Yaxing Wei from the Oak Ridge National Lab Distributed Active Archive Center. So here I'm going to briefly introduce the NASA USDIS, the ORNL DAAC, and also give you a really brief demo on how to find and access DeltaX data from the ORNL DAAC website and through the NASA USDIS tools and services. So the NASA Earth Observing System and Data and Information System, USDIS, is a comprehensive data and information system designed to manage and distribute data collected from Earth observing satellites and other Earth science missions. And USDIS consists of 12 distributed active archive centers, or DAACs, and each specializing in different Earth science disciplines. And the ORNL DAAC, here located at Oak Ridge National Laboratory in East Tennessee, specializes in data for biogeochemical dynamics, ecology, and environmental processes. So the ORNL DAAC was established back in 1993, and its mission is to assemble, distribute, and provide data services for a comprehensive archive of terrestrial biogeochemistry and ecological dynamics observations and models to facilitate research, education, and decision-making in support of NASA's Earth science. The ORNL DAAC serves as the primary data repository for data derived from NASA's terrestrial ecology program and carbon cycle science and ecosystems focus area. And this is the ORNL DAAC website. So dac.ornl.gov, feel free to check it out. Now, over the past 30 years, the ORNL DAAC has published a wide range of data products, many of them collected from field and airborne campaigns, The current active data holdings of the ORNL DAAC include more than 1,800 datasets in 9 science themes from 41 research projects or missions. So during a 6-month period, during 2023 October to 2024 March this year, the ORNL DAAC distributed more than 1.5 petabyte of data to more than 30,000 different users. And this slide shows the logos of selected projects and missions supported by the ORNL DAAC, including NASA's Arctic Boreal Vulnerability Experiment above, the JEDI Global Ecosystem Dynamics Investigation, the Airborne Visible Infrared Imaging Spectrometers, Everest Facility Instruments, and of course, the Delta-X mission. So the ORNL DAAC provides comprehensive support to the Delta-X mission in publishing and enabling use of its data. The ORNL DAAC works closely with Delta-X investigators and publishes data through a semi-automated ingest pipeline into the NASA Earthdata Cloud. It's an Amazon Web Service AWS cloud-based platform to facilitate storage, access, and analysis of our science data. And as illustrated in this diagram, users can find, subset, and download data from the Earthdata Cloud to their local computers for free, as usual. Users now also have the option to work in the AWS cloud and access the data directly in the cloud without the need to download data. So the ORNL DAAC does a lot of work to make this happen, including data quality assurance and quality check, documentation, metadata curation, enabling data search and access through tools and services, like collecting usage metrics and providing long-term data preservation and also user support. So next, I'm going to quickly demo how to find and access Delta-X data. And the demo contains 2 parts. The first part is a live demo of finding and accessing Delta-X data from the ORNL DAAC website. And the second part contains a series of screenshots that give you an idea of using different enterprise tools, services, and APIs to find and access Delta-X data from and also in the NASA Earthdata Cloud. Now, let me get started with the first part of the demo. Let's click on the link dac.ornl.gov, and it will take us to the ORNL DAAC website. This is the ORNL DAAC homepage. And from here, you will see a few options, top-level menu items, about us, get data, submit data. But for this demonstration, let's click on get data. And from this page, you will see a few options to explore ORNL DAAC data holdings, including by science themes, by projects, or simply browse all datasets in the ORNL DAAC data holding. And here on this page, you see a list of all projects that had published data through the ORNL DAAC. And let's scroll down a little bit, and we will see Delta-X. Of course, you can use the search feature on the website as well, but for the sake of the demo, just scroll to Delta-X here, and let's click on the logo of the Delta-X, and it will take you to the Delta-X project landing page. And from this landing page for Delta-X, you see a brief overview of the Delta-X mission and a list of all the datasets that have been published through the ORNL DAAC. Okay, as of today, there are 45 datasets from the main Delta-X campaign and another 15 from the Delta-X demonstration or the pre-Delta-X campaign published. Note that these numbers will change as new datasets or new versions of data coming into the ORNL DAAC for publication. And here in the table, the title hyperlinks will take you to the individual data set landing pages, and you can have a sense of what kind of data that have been published through the ORNL DAAC here. But let's just randomly pick one, maybe this most recently published data set. This is a modeled land creation rate map that was published maybe earlier this month. Let's click on the hyperlink. And here is the dataset landing page for this particular dataset. And here on this landing page, you see some really important information about the dataset, the DUI of this dataset, and a brief description of this dataset, and some fundamental metadata information about this dataset, like the spatial coverage and a preview of the spatial location of this dataset, and the temporal coverage of this dataset. And the citation information. And this is really critical, and you should include the dataset citation in the reference of your publication if you use the data. And then there is this data file table, which lists the individual data files, and you will be able to download the data directly from here. But you will need a free Earthdata login account to download data. So if you do not have an Earthdata login account, feel free to sign up. Now let's click sign in to just log in. And then it will take you back to the landing page. Now let's scroll to the data file table again. Now you see the file names are now hyperlinked, and you can click on the file names to directly download the data from the ORNL DAAC website. Now I'm going to point you to the user guide of this dataset. This is really, really important. So from the top of the landing page, you see there's the link user guide. Let's click on it. And this user guide, you can see an overview of this dataset. And you see the dataset characteristics and potential applications and use of the data, quality assessment methodology and results, and also information about how the data were collected or created. So such information provided in the user guide is really important for you to fully understand the data and use the data properly. Now, let me switch back to the presentation and start the second part of the demo. So cloud migration is a major effort going on at NASA Earth Data System. The ORNL DAAC has made all its data holdings, including the DeltaX datasets, available in the NASA Earth Data Cloud. Having data in the Earth Data Cloud has many benefits. There are many different enterprise tools, services, and APIs that users can use to find and access data not only from the cloud to your local computer, but also directly within the cloud. Now let me start with the NASA Earthdata Search client. This is a powerful web user interface that users can find all NASA Earth science data, not only those published through the ORNL DAAC. But in the Earthdata Search client, you can use the filters, like this project filter, to show only those datasets from the DeltaX project. And you can use other filters like the platform filters, instrument filters, to basically see, for example, only the airborne datasets or the modeled products. Or you want to see datasets from a particular instrument like AirSWOT or UAV-SAR or Everest-NG, you can do that through the search filters available from the Earthdata Search client. Now let's take a look at this, for example, the Everest-NG level 3 derived water quality, total suspended solids and turbidity dataset. Note the little label here, Earthdata Cloud. It indicates that the data is available in the Earthdata Cloud. Now let's click on this dataset in Earthdata Search client. we will drill into this dataset and see all the granules or data files within this dataset. So this is a screenshot of how that granule level information looks like. And on the right side of the screenshot, you see the footprints of the spatial coverage of all the granules for this dataset. Now let's click on the little plus icons at the lower left corner of each granule to add some granules to the shopping cart. And then click the download button here, and it will take us to the, this is the shopping cart itself. From here, you can click the download data, and then you can easily grab the data and download the data files to your local computer. There is some details here I would really want to show you. So you notice the little eye, the info icon to the right side of each granule. Click on it, you will see some really detailed granule level metadata information. This is the little eye icon. Click on it, you see the detailed metadata information. This is really useful if you really want to drill into the technical details and do something, play with it. And within the detailed granular level or file level metadata information, you can get a lot of additional information like this one. This is the URL to the AWS Cloud S3 bucket that you can use directly to access data in the cloud. And you can also find out, for example, which services this file is associated with, like this OPeNDAP service. And there's a URL, if you notice here, and following this OPeNDAP URL from the metadata, and you can access a very simple user interface. This is the OPeNDAP user interface that allows you to subset the data, either by variable or by dimensions. You can choose time or space. And you can also have the option to reformat the data to different options. And you may say that I don't want to do all these manually, and I just want to search and access data in a programmatic way. And you can leverage the common metadata repository, the CMR API, directly. By the way, the CMR is the search engine powering the Earthdata Search client you just saw in the backend. And leveraging the CMR API, you can easily search DeltaX datasets and filter granules of a dataset in the spatial area and temporal range, for example, as illustrated on the examples here on the screen. And of course, you can do much more with the CMR API. So feel free to check out the CMR API documentation. And you may also say that I'm kind of familiar with another API, which is called SpatioTemporal Asset Catalogue STAC API. And the STAC API is really becoming more and more popular recently. CMR supports it too. Here are some example STAC requests that allow you to kind of explore datasets and filter items. And that's the term used in STAC. This is kind of similar to the granules or files in CMR by space and time. So similar to what you can do with CMR API, you can do that with STAC API. And the request examples here show you how to do that really easily. And feel free to find out more at the CMR STAC API documentation. And you may also say that these are too complicated. I don't care about those technical details. I don't want to learn those API or services. I just need a super easy way to find and access NASA data with just a few lines of codes. And here you have the earthaccess library. It's an open source Python library with contributions from the NASA OpenScapes project and multiple DAACs, including the National Snow and Ice Data Center DAAC and SIDC DAAC. And the earthaccess Python library is super easy to use. So you just install and import the module, as shown in the code snippet here, use one line of code to handle Earthdata login and another line to search data of your interest using like the spatial and temporal criteria, and another line to just download the data to your local computer or access data directly within the NASA, within the cloud, AWS cloud, without the need to download the data. And if that's what you prefer, if you prefer cloud-based analysis, you can do that really easily. You can find a lot of more information about earthaccess library from the GitHub repository here. Due to limited time, I'm not able to cover all the topics and details. Here are some additional resources that you can learn more about NASA Earth Science data, how to find and access to use them. And at ORNL DAAC, we have a learning resource repository, provides you really useful information, tutorials that you can check out. The NASA Earth Science Data Learning Center also has a lot of useful resources, including all the past Earth Data webinar recordings. And of course, contact us via Earth Data Forum and ask any questions you may have, or find out what other knowledge that other experts have shared. So it's a very useful place to find out more information about the data, about the services and tools. So that's all I have. I'm going to transition back to Kathleen. Thank you.
Are you seeing my screen?
Yes.
Okay, thank you. Okay. Ah. So I'm going to talk about more about the data and the modeling, and also about the processing tools, and so give you some information about where to find publications relevant to Delta X. So Delta X made a lot of measurements, and from each of those measurements, the observables were collected, and those are all available at the ORNL DAAC. From those, for example, we did a map of the channel network. We did sediment, total suspended sediment. We did vegetation classification. All of that is derived products, and they're also available. And of course, then those were used in models, which are also available. So one easy way to look at the data, in particular, to look at the data, in situ data, is to use the Delta X website. And if you go to the Delta X website and you click on the data and download, then it will take you to a page where you can do a convenient data search. For example, what I have shown here is all of the in situ data and the locations where the in situ data were collected. If you're interested, for example, only in biomass, you can select the biomass. You can also, these icons indicate where water quality data was collected, soil data, discharge, water level, all kinds of in situ data. And it's actually very convenient. Even if you get the data from the DAAC, then you can also use this to visualize where those data sets were collected. So for example, this is one of the intensive study sites in our region. And if you zoom in, this is what you would see. It's an area where a lot of data was collected. An even closer look at it would give you something like this. And then if you clicked on this feature, a pop-up window would come up that would take you to the landing page at the ORNL DAAC, and then you download it like Yashin was saying. You can also use that website to look at the publications just by clicking on Science and Publications, or also meetings there. It takes you to the publications. If you look at a publication, you can see the entire list of publications that have used Delta X data. If you read a publication and you're interested in the data, you can come to this website and you can view the data directly that was used for this particular publication. And in the case that there was a model, you can also get information and links to the models that were used. Probably the most important thing for you is the toolkits that were developed for handling Delta X data. Those were presented at applications workshops, one in 2022 and one in 2024, both in May. They were held in Baton Rouge in 2022. That was early in the analysis pipeline, and that workshop focused on data, how to access the data and use the data. The most recent workshop focused on the models, now that we have those developed. So, for example, the first application workshop, all of these observables, tutorials, and tools for visualizing and working with those were developed and made available. And then in 2024, these numerical models were also made available. So another way to access that, besides going to the DAAC directly, is you can go to the meetings drop-down menu here, and you can click on the 2022 applications workshop. That takes you to the link to all the resources on ORNL DAAC. And similarly, we're preparing, and soon we'll have that up for the 2024. So if you go to the 2022 applications workshop, for example, you can see the agenda, where you can see that information about the field data and all of the different airborne instruments were presented. Now, if you click on this link, workshop content, it takes you to the GitHub location where all of the tutorials and slides are stored. I suggest that if you go here and you're interested in running the tutorials, then you click on the workshop instructions. That will take you to a set of instructions about how to download the data and how to prepare your computer so that you can run these codes on your own computer. For instance, all of these have in the tutorials, there are Jupyter notebooks for handling the field data, AirSWOT data, AVRIS-NG data, and UAVSAR data. They're also in the 2022 workshop. There is the Python code, instructions, and examples for the ANUGA model. Now, I'm just going to show you an example of using AirSWOT as the example. If you go to the tutorials for AirSWOT, there are 3 of them. The first one allows you to read and visualize all of the AirSWOT products. The second allows you to calculate the water surface elevation and slope from a data set, subsetting the data to a particular area. And the third does a comparison of the results from that to water level gauge data that was acquired during the Delta X campaign. So let me just see if I can bring this up. Good. Okay. So this is the first AirSWOT data instruction Python notebook. It gives a very complete overview of AirSWOT references, talks about the processing levels, and then how to download those products, what their different layers are, and how to visualize them, and other information like extracting and visualizing the slope and water level. So going back, If you are unable, however, to install all of this on your own machine, then you can also use Google Colab. These modules have all been put into Google Colab so that you don't have to run them locally. You can simply go to this site and click on Open in Colab, and then you can run them from Colab directly. However, you will need to look at the instructions for how to set up data access for the tutorials if you plan to run them yourself. So, for example, if you look at the second AirSWOT notebook on estimating water surface elevation and slope, I'm just going to bring that up because it's an excellent example of how these tutorials can be used for your data sets. So this goes through reading in the data, subsetting the data. Here it's been subsetted to a lake, how to make a mask of that area, how to refine the mask of that area, and then how to get the AirSWOT surface height, water surface height from that data set, how then to use it to calculate a slope and for that area. In addition, you can also use this code to plot how that particular area's water level change, water surface elevation changed with time, and also how the slope and direction of slope changed in time. So this is an excellent example of the capabilities that are available through this, through these applications workshop. So let's see. In addition, on ORNL DAAC, there are video presentations that go with each data set and tutorial, and you can follow along as the instructors who all made these these tools themselves teach the people at the workshop. The second applications workshop, which was just held in May, focused on the models. The recordings of the tutorials will be posted on DAAC soon. However, the GitHub page is all set up. There are tutorials and for Delft 3D, for Anuga, for Dorado, for Telemac. So if you want to just get the models directly, then you can just go to ORNL and type in DeltaX models. And I want to say that my colleagues, Alex, Ali, and Antoine are very involved in doing the modeling and or on the panel in order to help with questions and answers. So thank you. I hope you use the DeltaX data sets and the DeltaX tools. Thank you.
Okay, well, thank you very much, Kathleen. So at this point, I'm going to open up the end optional polls, and then we'll jump. I don't see any questions yet, so if anybody has any questions, please enter those into your Q&A panel. Let me open the poll really quickly. And we're doing great for time. All right, let's take a look and see if we've got anything in the chat. I looked a second ago and I didn't see anything, but let's check. Surely we must have some questions for our speakers today. All right, let's see. Somebody's got to be the first one. All right, let's check it out and see if we have any questions in the Q&A panel. Not yet. I don't see any questions. This is going to be a first ever in over 200 something webinars. We must have questions for our speakers. There we go. Michaela, thank you. All right, so the first question is, what would you say that the most challenging aspect of the mission is?
I can answer that, having been there. You know, we had all of these assets in the field in southern Louisiana, which is not known for its great weather, calm weather. And so coordinating the the field campaigns with the airborne campaigns. And the field campaigns, you know, my last slide showed what it looked like out there. This is a very flat area. You do not want to be out whenever there's lightning strikes coming in. And then just to make it even worse, we were out there during COVID. So all of the field teams and the airborne teams had to individually isolate together from each other. And then last we had a hurricane hit at the end of fall. So we had to depart the field very quickly. So it was quite a challenge.
Kathleen, can I add something? I think you covered it really well. I want to mention that DataX did deploy some flights, average NG flights, to capture the impact of Hurricane Ida that happened in September 2021. And the data are available from datasets published through the ORNL DAAC. So that's very interesting.
Yeah, AirSWOT data was acquired before and after, and average NG data was acquired before and after.
Okay, well, thank you very much both for your feedback there. Just checking to see if we have any additional questions. This is your opportunity. You have the deputy principal investigator here, and you have 3 members from the Delta X science team. There's got to be,
Alex
gotta
has
be
been
something.
working a whole lot on the organic production model. Ali has been doing Delft 3D, great. And Antoine is an expert on Anuga. So that's why I asked them to be on this panel in case there were questions about those aspects.
All right, well, why don't we give it a couple of minutes here. And then while we're waiting to see whether or not there are any additional questions, and I do hope that there are, just a couple of points. So what we'll do is generally I leave the virtual meeting space opened you know, for 10 minutes after we log off from the audio component, just to give people an opportunity if there's something that you didn't think of and you'd like to jot that down. We will send the, you know, Q&A log and the any questions that might appear in the chat along to our speakers. And so, you know, that's the first. And then the second is I will leave the optional final polling questions open for, I think we probably have like 25 minutes left on those. And then finally, for those of you, if you joined a little bit later and didn't catch it in the chat, let's hear that question. I saw a question appear and now let me see.
And there's one in the chat.
I'm glad. Okay. What I was going to say is we are recording today's event, and I will make the recording and the presentation slide decks for all 3 parts available to all participants and also registrants if you have any colleagues who are unable to make it today. So our next question is, can the surface water mapping tool be applied to other deltas?
Yes, it can.
Okay, well, thank you, Kathleen. And our next question is, would you ever consider using a different programming language for interpreting the data?
Kathleen, you want to address that or you want me to?
Well, let's see if Alex, Ali, or Antoine want
Sure.
to address that.
Yeah, so I think Python was chosen because it's generally open source and is becoming quite popular, especially for earth science. So I don't think there's any plan to use a different programming language. There are people on the team who've used MATLAB, for example, but I think we're trying to stick with something that any user can get access to.
Perfect. Thank you so much, Alex. And our
Jennifer,
oh, go ahead. I'm
can
sorry.
I add, I'm quite interested in learning what I think Michaela, what kind of programming languages that you prefer, so we can probably invest some resources on developing tutorials on demonstrating how to access and use data in the programming languages you you want to use.
Sure, that's great. So Michaela, if you'd like to provide some additional details in the Q&A panel, that would be super helpful. And then in the meanwhile, I'm going to hop up to the chat because we do have a question there. So our next question is, how does the prevalence of wetlands affect the ability to model water levels and groundwater levels?
Ali, do you want to take that?
I can unmute, but you should be able to unmute yourself. Let me see here. Oh, no, you're unmuted. We don't hear you.
Can you hear
Ali.
me now?
Yes, yes, we can.
Okay,
Wonderful.
so
Thank
I'm
you
using
very
Alex
much.
microphone, sorry. So obviously running a model for a low-lying region with so many wetlands is a difficult job. But we are using specific models for those areas, models that solve shallow water equations. Those models are built specifically to simulate hydrodynamics of those regions. So, and also having wetlands with so many small rivers, bayous, and channels makes the geometry complicated and makes everything difficult. But we are we have tried to run high resolution models. So in order to be able to resolve all those small geometries.
Well, thank you. I really appreciate your response, Ali. And so we do have an additional question here. Could you explain a bit more how the organic matter production model works?
That's clearly Alex.
Yeah, so it's basically a unit model. So we give it how much mineral sediment deposition there is, which comes from one of the Delft 3D sediment transport models. And then we also have estimates of above ground biomass, which we can then use to estimate how much root biomass there is. And then we simulate the model on an annual time step. So each year, the plants produce a certain amount of below ground biomass and organic material, which adds to the surface elevation, and then also the mineral deposition, and that slowly builds up the elevation of that unit. And then there's different types of decay from decomposition and subsidence that would make the surface elevation go down. And then we run that for many years to get a estimate of the mean accretion rate that happens at that point for 50 to 100 years.
Well, thank you very much for that response, Alex. And so our next question, I think I'm going to take this one. There are several parts to it. And so I will start with the first part. So the first part of this question is, how is your experience with D3D in modeling sediment transport? And then the comment with that first part is, it's quite tricky to do sediment transport for large surfaces and for a longer time, so compromises must be made. So let's address part one first, and then I think there are two other questions built into this comment.
All right, I think he means the Delft 3D by D3D. I try to answer one by one. Yes, it's quite tricky to run a morphology and sediment model and predict the future for like the next 100 years. But the Delft 3D has this option to apply a morphological factor so that you can accelerate morphological processes. As we know, morphological processes are much slower than like hydrodynamic processes. So we cannot run a high resolution model for 100 years. What we do is that we run a model for like 50 days, and then we apply a morphological acceleration factor in the model. And then we estimate the future based on that morphological acceleration factor.
Also, Ali, I think that you also, get the average wind direction and conditions and use that use a distribution in your model also for those 50 days. Is that correct?
Yes, we try to design our forcings or our boundary conditions based on average conditions. As Kathleen explained, we have high river season and low river season. We have had field campaigns and airborne campaigns in both seasons. Also, wind direction in that region is totally different during the winter, that we have cold fronts, but in other times we don't have cold fronts. So that future forecast scenarios, those scenarios use boundary condition and also forcings that are designed specifically to be the representative of the average condition in that region.
Well, thank you very much. I don't think we've addressed the other two parts to this question. Okay.
The second part asks, how did you manage to model combined sand and fine grain sizes, transport and deposition? Particularly, how did you define fall velocities? So we tried to calibrate the model, specifically the shear stresses and fall velocities based on average NG TSS data. We tried to, we calibrated we changed the fall velocity, for example, and then tried to minimize the error between the simulated TSS and also average NG drive TSS. That's how we calibrate TSS, calibrate fall velocities. Obviously, we cannot have so many sediment fractions in the model. It's just impossible to run the model with so many sediment fractions. We are having just 2 sediment fractions, one for sand and one for mud. And the grain size for those 2 sediment classes are defined based on our field campaigns that measured grain sizes in that region.
Thank you very much. And then I think the last part of this question is, what are some best practices for deltas in using D3D at a larger scale for sediment transport?
I'm not sure what he means about best practices, but I guess our study domain has a river-dominated delta. It means that river discharge is very important. And Delft 3D has this option to run models both on regular grid and also irregular grid. I guess specifically using a flexible mesh. This is something that we are working on. It's in progress. Is the best practice for those regions with complicated geometry. So you can have coarser resolution on the offshore area and a very high resolution in small channels.
Okay, very good. Thank you. I am just looking to see whether or not I have. Need to see if there are any
The
additional.
question is about plans to transition to a different language. I think we're sticking with Python.
Yes, and so there was a follow-up from our participant, and she was noting that she's an intern at ARC and not super familiar with Python, so her mentor has been helping her to use JavaScript and R in Google Earth Engine and QGIS. And so it was more of a curiosity if there are any plans to transition to a different language, in case it would be good to learn that too.
Jennifer, I want to add a comment on that. I think
Sure, of course.
question really contains 2 parts. One is the data use part. I think the toolkit that DeltaX team has developed, Python was definitely their top option, and there's no plan so far to transition to a different programming language. But the second component I see in Michaela's question is the data access part. Even though Python is also our top priority option in developing tutorials and examples, but I want to point out that because of the standard interfaces that ORNL DAAC as well as NASA developed, like the CMR API or the STAC API, because they are standard, you can easily plug those APIs into the tools or programming languages that you are already familiar with. You can connect them directly. For example, the STAC API, you can leverage STAC viewer plugin for QGIS. You can directly import the NASA Earthdata STAC API endpoint into the QGIS plugin. You can perform data search and even add the data to QGIS directly from there. So the interoperability part is in our mind.
Thank you, Yashing. And so what I have done is I placed a link to both the Common Metadata Repository API and also the CMR Stack API in the chat. And from there, you will find links to the documentation for both as well. I'm not seeing any additional questions at this time. Let me just do another, oh, my apologies, go ahead.
Oh, I was just going to say, if you have a delta that you're interested in or a region of interest, in the polling questions, there is a place for you to put that in. And that's something we really want to hear from you about. So don't think it's just going to be ignored.
Yes, thank you. That's a good reminder. So I will leave the polling questions. I think we've got another 11 minutes or so open for the polling questions. If there are, I'll do one more scan, both in the chat and then in a Q&A. If there are no more questions, we will, let me just, I do see something coming through in the chat. We will wrap up this afternoon's session, and I will leave the virtual meeting room opened an additional 10 minutes. All right, no questions in the chat. Let's take another peek down at the Q&A. Make sure I haven't missed anything. All righty. I don't think so. I don't think so. So with that, I would like to thank our 3 science team Q&A panelists, Alex, Ali, and Antoine, and also our speakers for this afternoon session, Kathleen Jones and Yashing Wei, for their contributions and responses to the questions, and also really to thank all of you for taking time out of your day to join us this afternoon. We really appreciate your feedback. As Kathleen said, the responses to these questions are extremely helpful in identifying data user needs, maybe potentially where there are gaps, and also in really determining future topics for our NASA Earth Data webinar series. So with that, thanks to all of you, and I will log off from the audio component and leave the virtual meeting space opened. All right, thanks so much, everybody. Have a wonderful morning, afternoon, or evening. All right, goodbye now.
Thank you, everyone.
Attending and asking
you.
questions.
Absolutely. Thank all of you.
This time we got better.